All right, okay, you can hear me. Good. All right. So I will try to talk loudly. I know you're probably having some good conversations about H2O and driverless and machine learning over lunch, but hopefully I can distract you for a moment with a talk about scalable, automatic machine learning with H2O AutoML. So those are all very sort of buzzwords, but they all actually have meaning here. So what we're talking about with AutoML is a very truly scalable system that builds on top of the scalability of H2O and does automatic machine learning. So, all right, so I am the chief machine learning scientist at H2O, and this is a product that I have worked on. So I work in concert with my colleague Navdeep Gill on this, and also we have a few other people that help from time to time. So this is what I'm going to talk about today. So first I'm going to just give an overview of what automatic machine learning is, and then speak specifically to what H2O AutoML is, and then I'm going to sort of go over some pro tips. So if you want to just get out your laptop later and try this out, I'll give you some helpful tips on how to best use the system. And if you want these slides, I made them available at this link. So I'll also put that URL at the end of the talk as well. So, and actually all the slides and videos will be online later. Okay, so what are some of the aspects of automatic machine learning? I like to break it up into kind of three pillars of data science. So one, we have all of the data preparation. So if you have to get your data into a tabular format, if you're doing feature engineering, anything like that sort of goes under the data prep regime. So then we next go to modeling. So once you have the data kind of all set, ready to go, you do a lot of modeling. That could be grid search, it could be Bayesian hyperparameter optimization. It basically covers any sort of building of the models. And then once you have a large number of models, you can either sort of pick the best one out of that set, or you can further enhance your accuracy by ensembling them together. And so when we talk about automatic machine learning, what that means is sort of automating all of these three things. And just to be a little bit more specific about some of the points in each of these categories. So data prep could be filling in missing values, doing feature selection, dimensionality reduction. Some of the more sophisticated stuff is when you have categorical columns, and especially high cardinality categorical columns. Like let's say you are a healthcare institution and one of your columns that you have in your data set is ICD-9 or ICD-10 codes. There's like thousands of these codes. How do you best make use of that data? There's all sorts of tricks that you can do and apply to categorical features that will really, really improve your model. So I would consider all of that data prep. And then in terms of modeling, we could do just sort of the more straightforward stuff like Cartesian or random grid search. That's an easy way to generate a lot of models quickly. And for each of those models, you can sort of tune them using a validation set. And then there's another technique called Bayesian hyperparameter optimization, which involves using sort of a helper model that will help you decide what the next best set of parameters should be. So you train a model, you pass on the parameters and the score, and it gives you a new thing to try in kind of this like loop thing. And so these are all just different techniques of modeling and producing a lot of models. And then once you have a bunch of models, you can either do model selection and just choose a best model, or you can do something like stacking. So stacking is something I'll talk a lot about today, and that's what we use in AutoML. What that is basically using a machine learning algorithm to figure out what the best combination of these smaller algorithms in your model is. So it's sort of this meta-learning or second-level machine learning step. And there's another type of ensemble selection, which is a greedy approach to adding new models into your ensemble. And then there's another, let's say technique. It's sort of more of a generic term, but another type of ensembling called blending. Okay, so most of you probably are familiar with H2O, but just in case this is your first H2O World or your first introduction to H2O, what makes H2O unique is that, one, it's open source, it's distributed both on a single machine and in a multi-node setting, and we have what we think are all sort of the cutting-edge machine learning algorithms that people want to use. And all of that's written in high-performance Java, and then that's running either on your laptop or on a server, and you connect to that server from R or Python. And so if you can, if you're on the internet, you're on your laptop, and you have something running on AWS, you would just connect to that. But so often people do run it on their laptop, but when you're using big data sets, they're running it on a big machine that you have at your company or institution or on AWS. And so basically it uses the internet to connect, so REST calls. So if your internet goes down for whatever reason, you lose the connection to the H2O server. So we make that pretty robust. And then the other good thing is that you can deploy models as pure Java code. So that's very efficient if you're an enterprise shop. And then it sort of works everywhere: Hadoop, Spark, AWS, your laptop, et cetera. Okay, so back to AutoML. So this is basically what H2O AutoML has in it of this wide set of things that I've named so far. So in terms of data prep, we have some basic stuff that makes your life a little easier: imputation, one-hot encoding, and normalization. And then we will be adding some basic target encoding as well. So this is actually a category in which driverless AI is very, very strong. So so people often ask, what's the difference between AutoML and driverless AI? This is one of the main categories that they differ. Is driverless has completely automatic feature engineering and generation. So and AutoML does not. So the modeling aspects of the two are actually quite similar. So well, they're different, but in terms of we produce a whole bunch of models and then we ensemble them. So in AutoML, what we do is a big random grid search of each of the different algorithms. So we do a big GBM grid search, deep learning, et cetera. So we hit all the algorithms, do a random grid search using a set of parameters that we've chosen sort of manually as data scientists, knowing what we think makes sense. And then we do stacking on top of that to really get good performance out of AutoML. Okay, so this is kind of just an overview of what I just said. So basically, one thing I'll just note here that I haven't said yet is at the end we'll do 2 ensembles. So one of them would be all of the models. So if you have 1,000 models or 100 models, however many models you have, we will ensemble all of them together. And that generally is the best model, but typically if you're going to production with a stacked ensemble, you probably don't want 1,000 model ensemble. It might be a little bit slower than having one model, for example. But what we can do is we can take the best GBM, the best deep neural network, best random forest, and make sort of a lightweight stacked ensemble that would be optimized for production. So depending on your use case, if it's just pure prediction, you would go with like just ensemble everything. That's how you're going to win Kaggle. But if you're really taking this to production, we want you to have something a little bit more lightweight. And then what you get back is what we call the leaderboard. And that's kind of a term borrowed from the competitive data science scene. So what you get back is, well, let me skip ahead. Well, no, I won't. I'll just describe it. So basically just a list of all the models that have been trained and their performance on a bunch of different metrics. And you can specify what metric you want to sort by as of H2O 320, which was released today. So I should put a caveat that you can sort starting today. Okay, so what are we going to add to H2O AutoML? Because it's a fairly new creation, so it's less than a year old. Some of the big things that we're excited about is we're adding XGBoost into AutoML. So XGBoost is a very good implementation of a gradient boosting machine. It's similar but different than the H2O GBM. Has very strong performance, and so we have had XGBoost inside of H2O for a little while now, and so we're in the past, release doing a lot of work on stability of XGBoost, and now it's pretty stable, so now we're going to put it in AutoML. So that's coming up soon. And then I mentioned we'll do some basic target encoding. So if you have any sort of really high cardinality categorical features, it's not going to sort of blow up, basically. So if you put a ICD-9 column in there, or zip code, or something with a lot of categories, we'll try to take care of that for you. And then we want to work on some improvements to the random grid search space. So we kind of gave it a first pass, and I think through a series of a lot of rigorous benchmarking, we can improve upon that. So improvements for imbalanced data sets. So this comes up a lot in like industries where you do fraud prediction, where you have a lot of examples of not fraud and very few examples of fraud. So we're going to make improvements for that. And so also in the new release of H2O that came out today, you can manually turn on class imbalancing yourself, and then in the next release, we'll do that all automatically for you. So new ensembles, so there's other ways that we can choose which models we want to put in a stacked ensemble, and we're also looking at some of the other types of ensembles to add in as well. And then this summer, we're working in collaboration, kind of in a consortium of some academics and people that are very passionate about machine learning benchmarks, the OpenML.org Foundation. So they are basically, what they do is machine learning benchmarks, and we're working with a team of their people this summer, and 2 of them are going to come work at H2O over the summer, and we're going to sort of build an AutoML benchmarking public system so that anyone can benchmark their AutoML systems on this, and we all have complete visibility as to where these systems are performing well, where they're not, and then we're going to use that as a process to improve AutoML. Okay, and just if you haven't seen AutoML before, this is kind of what it looks like in the Flow GUI. So once you start H2O on either your laptop or a cluster, it always starts up a web server. And so even if you're using R or Python, you might not use the web interface. It's there for you if you want it. So basically, it's just one button to run AutoML from Flow. If you go to the Model tab, the first thing down says Run AutoML. And this screenshot is missing some of the features that we just put out today. But basically, you just give it your training frame, tell it what you're trying to predict. So you would, once you select the training frame, more columns will pop up. So you select the outcome column or the response column. And then essentially, you just tell it to go for however long you want it to go for. So if you want it to run for an hour, or if you want it to run for a day, 24 hours, or you can also specify the number of models that it will train. So if you want to say, stop after 100 models, and then we also have what we call early stopping settings. So even if you set a large time limit or number of models, if it starts to realize that the new models that it's creating are not adding any value, then it will stop early as well. But you can turn that off too. And so this is what it looks like in R. So basically very similar to the H2O, any H2O algorithm where you specify a training frame and the name of the response column. And then there are some other parameters that I'm not showing you here, but these are the basic ones. So what's your data set? What are you trying to predict? How long do you want it to run for? And it will go off and do all of that stuff. And then what you get back is your leaderboard. And same thing in Python. This looks a little different. It's more Pythonic. You first create an instance of a class AutoML, and then you invoke the train method to actually kick off the training. And you get back a leaderboard. And a leaderboard might look something like this. So this is on a real data set. I think it's only something like 10,000 columns. It's probably the Higgs data set, which I use for all the demos, or a subset of the Higgs data set. So if you go to the AutoML user guide, you'll see the same data set here. So what you might want to notice in here is, so at the top is kind of what you might expect. It's not always the case that the stacked ensemble will be at the top. It typically is. If it's not, it might mean you don't have enough data. or or your data is very strange and it's not able to make sense of it. But what you see is, stacked ensemble, all models at the top. Next one down is the best of family. That's what we call the sort of lightweight production version, which is not as good as the full one, but pretty good and still better than the top single model, which oftentimes is a GBM, not always, but again, these are just sort of trends that we notice. And so something also to notice is sort of the difference between the GBM top performance in terms of AUC. So we have 0.78, and then the ensemble is 0.788. And so if you were playing Kaggle, like the difference between just giving your best model, your best GBM, and doing a stacked ensemble of all your models, that's like 500 slots on the leaderboard or something like that. So when you're playing Kaggle, you're like into the last, 4th decimal place or something like that, trying to, get the best performance. So my opinion is if you've already done all the work to train all these models, you might as well just run a stacked ensemble, see what happens. It's probably going to give you better results. And it's very easy to do in H2O, outside of AutoML and within AutoML. Okay, so I'm just going to skip over a few. I have about 4 minutes left. So before you blow up your AWS bill, let's talk about what's going to happen. So again, let me just warn you, we put an hour default on AutoML just so people don't get out of control and run AutoML for 5 weeks and forget about it and rack up an AWS bill that makes their boss unhappy. So just some tips. So basically, one, we ask you just to provide the training set, and so you don't have to do anything. You don't have to think about validation frames or test frames or any of that stuff. We will chop off a piece of your training data to use for validation. But if you want to control what that percentage of the data is, then you can specify a validation frame yourself and just do the splitting beforehand. Just a warning, don't use leaderboard frame unless you really want to. So if you want to score the leaderboard on a specific data frame, you can do that. But what we will do, what we would recommend that you do is just don't use that. Use the default, which is we would use cross-validation metrics, because that way you make the most use out of your data. Okay, so this is kind of some tips for different types of data. So we have an argument called the exclude algos. So when we first put AutoML out, one of the first things people asked for was, could I turn on and off different algorithms if I know that I don't want them, or if I want to focus only on GBMs or something like that. So we exposed an argument which allows you to do that. So for example, if you have, let's say, text data, and let's say it's very wide and very sparse, you might want to turn off the GBM or random forest, or you might want to do some dimensionality reduction first, like word2vec or PCA. So these are ideas that we can give you. Any ideas that we're giving you, these are also things that you'll probably see in the product later. So these are sort of, okay, we thought about this, we should probably add that automatically, and give you, of course, the ability to turn it on or off. And let's say you have time series data. So that's another popular thing that people have, especially in finance. So to use AutoML with time series data, it's not really set up to do that currently, but if you want to do that, you basically just have to turn off cross-validation, because if you have time series data, you shouldn't be doing cross-validation, at least in the traditional sense. And then if you want to do a validation frame, make sure that validation data is ahead in time than the data that you're training. This is just kind of a time series machine learning suggestion. And then I mentioned this before, so it'll kill itself after 1 hour unless you change the max runtime. And if you want it to be reproducible, you should use max models, because that is going to be the same models every single time as long as you set a seed. When you specify time limit, then maybe one run you had some amount of resources on your machine that let you train so many models. If you run it again, it might have more or less, so it might not be exactly the same. And then just a reminder, like all the models are in the H2O cluster. So if you know that you're going to train 1,000 models, you should probably give it more memory than you typically would if you're training 1 or 2 models. And I'm going to skip that. Saving models, basically these are H2O models, so they're just sitting there in the H2O cluster. If you want to save any or all of them, you can do that just by looking at the model ID and then clicking save. And if you want to figure out how to use this, go to this URL. It's going to take you to our GitHub where we have tutorials in R and Python. So that is it. That's, again, this link to the slides. You can follow me on Twitter or on GitHub if you do that, or you can send me an email anytime. Okay, thank you very much.